Good morning, all of you. Today we are going to start a very important topic in Introduction to AIDS. The topic is knowledge representation technique and forward chaining and backward chaining. Let's first start with knowledge representation technique. Basically, knowledge representation used for converting the real facts into some standard representation, so that we can convert the real facts in the mathematical expression or some logical representation, so that we can understand and find some relationship among the facts and we can conclude with some particular statement. There are three major techniques for knowledge representation, and we have included the logical representation, semantic network representation, and finally we will end up with frame representation. Let's start with logical representation. Okay, logical representation basically we can consider is a language with some concrete rules which deal with propositions and has no ambiguity in the representation. No ambiguity, that means if we represent a statement in a logical representation, then if we represent another statement or another fact in the logical representation, there is no common or there is no confusion between the statements. It will supposed to inherit some give some concrete meaning, and there is no confusion between the statements. That means two statements cannot deliver the same thing or same fact. And then the logical representation is basically categorized into two major categories. One is propositional logic, another is first order logic. And the propositional logic, here when we represent some facts in propositional logic with the help of some representation, then we are going to call that particular representation as well-formed formula. Those facts, when we convert in propositional logic representation, those representation is known as well-formed formula, and it's very simple to deal with it. And let's look into some facts, and we are going to represent all those facts into the propositional logic. Let us consider the first statement. It is raining, and we are converting into the propositional logic. We can simply write as raining, and there is no hard and fast rule that always we need to write raining. We can use some other term also, standard term also, not a problem. Let us look into the second statement. It is sunny, and we are representing it as a sunny in the propositional logic statement. Like that, other statements are there. It is windy, then we can represent it as a windy. Then here one conditional statement is there. If it is raining, then it is not sunny. Suppose the weather is rainy, then we can consider that if it is rainy, then it is not sunny. That means once it is true, then we can say that sunny is not true. And for representing this type of conditional statement, we are using the symbol implies. If it is raining, that means it is not sunny. Okay. Okay, let's look into the symbols and the sentences we use in the propositional logic. Here let us consider S as a sentence. Then if we put some negation in front of S, then that means that particular sentence is not true. Okay, as we have already dealt with this type of symbol in discrete mathematics, in other mathematical subjects, you have already gone through in digital logic design also. And then if we put some, it is quite similar to the NOT gate in the logical design, and negation of S is true if and only if S is false. That means this particular representation is true if the statement S is false. It indicates that. The second part, look into the second point. S1 and S2 are considered as two sentences, and then here representing conjunction, that means S1 conjunction S2, that indicates this particular part is true if and only if S is true and S1 is true and S2 is true. If both are true, then only that particular sentence is true. Okay, this property is known as conjunction. And disjunction, for disjunction, this part is true if and only if the S1 is true or S2 is true. That means both between the sentences either S1 is true or either S2 is true. If among the both sentences if anyone is true, then we can consider the entire part is true. Okay. Then the next is implication. We have already gone through implication. Then bidirectional. Bidirectional means if we are biconditional, sorry, if S1 biconditional S2, that means it is considered as true if S1 implies S2 is true and vice versa, the S2 implies S1 is also true. If it satisfies both the part, then we can consider this part as a true. Okay. Okay, now we will go through the logical equivalence. Okay, here are various property of logical equivalence. Starting from the, it is quite actually similar to the discrete mathematics properties. Start with identity, okay, then domination, idempotent, double negation, commutative, associative, distributive, De Morgan's law, absorption, negation. You can just go through it. If we do that, we have already gone through it. Conjunction and this symbol used for conjunction, this for disjunction. If the statement P is conjunction, conjunction with true, then we can consider this as a true. Okay, both are equivalent. Like we can write that conjunction, P conjunction true, that means we can simply write P, and this is part is also true. It is also valid for the false statements. Then domination. Domination means P conjunction, P disjunction true, the P is a statement, and P conjunction false. Okay, P conjunction true, then it will indicates true. If P disjunction false, it will indicates false. Okay, idempotent. Idempotent means if we are performing some operation with itself, that is idempotent. If we are performing conjunction with itself, we are going to get the same only, that is equivalent. If we are going to do disjunction with itself, that P disjunction is with P, then we are going to get the same part. Okay, double negation. If double negations are present, both will be cancelled out and we will get the same statement only. Then commutative. Commutative means if P disjunction Q and Q disjunction P, both are equivalent. If both the end we perform the disjunction operation, both are true, and same thing is valid for conjunction also. Then associative. P disjunction Q, then after bracket disjunction R. This indicates that first of all we are going to perform this operation first, then only with this solution we are going to perform operation with R. Okay, that means this part we are going to solve first, and with the solution of this part, the result, then we are going to perform the